NFPA 72, the National Fire Alarm and Signaling Code, doesn't specifically prohibit splicing wires at smoke detectors to connect to pull stations. However, it does provide general guidelines for wiring and installation. Section 14.41 states that all conductors of a circuit shall be contained within the same raceway or cable. Section 14.44 states that raceways or cable shall not be used as a substitute for listed equipment cabinets. The Massachusetts Electrical Code follows the requirements of NFPA 72. There are no additional state-specific requirements regarding splicing wires at smoke detectors for pull stations. While splicing wires at smoke detectors may not be explicitly prohibited by code, it is generally discouraged due to safety and reliability concerns. Firstly, splicing introduces potential points of failure that could compromise the integrity of the alarm system. Secondly, it can become difficult to troubleshoot or replace failed devices if wires are spliced in multiple locations. Thirdly, insurance companies may not approve of spliced wiring, even if it meets code requirements. Some alternatives to splicing can be considered. One option is to install a new circuit. Running a new wiring circuit specifically for the pulse stations can be a solution. Another option is to use wireless pull stations. Wireless pull stations eliminate the need for wiring altogether. A hybrid approach may also be considered. A new circuit for pull stations can be installed in critical areas, while splicing wires for pull stations in less critical areas. For the best safety and reliability, it is recommended to avoid splicing wires at smoke detectors for pull stations. If splicing is unavoidable, ensure that it is done professionally and meets all applicable code requirements. Document the splicing and obtain approval from the local authority having jurisdiction. Understanding the electrical code and fire safety standards is crucial when modifying or designing fire alarm systems. Before making any changes, always consult the relevant codes and standards. The electrical code is a set of regulations that govern the design, installation, and maintenance of electrical systems. The purpose of the electrical code is to ensure the safety of people and property from electrical hazards. Fire safety standards are a set of guidelines that are designed to prevent fires from starting and to protect people and property in the event of a fire. The electrical code and fire safety standards are constantly evolving as new technologies and best practices emerge. It is important to stay up to date on the latest changes to these codes and standards to ensure that your electrical systems are safe and compliant. One of the most important aspects of electrical safety is proper wiring. Wiring should be installed in accordance with the electrical code and should be regularly inspected to ensure that it is in good condition. Worn or damaged wiring can be a fire hazard and should be replaced immediately. Another important aspect of electrical safety is proper grounding. Grounding is a process of connecting electrical equipment to the earth so that in the event of a fault, the electricity will flow to the ground instead of through a person or object. Grounding helps to prevent electrical shocks and fires. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will automatically trip or blow when the current in a circuit exceeds a safe level, preventing damage to the wiring and equipment. In addition to these basic electrical safety measures, there are also a number of other things that you can do to protect yourself from electrical hazards. For example, you should never use electrical appliances near water, and you should always unplug appliances when you are not using them. You should also avoid overloading electrical outlets and extension cords. If you are not comfortable working with electricity, you should hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical hazards. There are several reasons why it may be necessary to splice wires in an electrical system. One common reason is to extend the length of a wire. For example, if you are installing a new light fixture and the existing wiring is not long enough to reach the fixture, you will need to splice the wires to extend their length. Another reason to splice wires is to repair damaged wiring. If a wire is cut or frayed, you can splice it back together to restore the circuit. Splicing can also be used to connect new devices or equipment to an existing electrical circuit. For example, if you are adding a new outlet to a room, you will need to splice the wires from the new outlet to the existing wiring in the wall. When splicing wires, it is important to use the proper techniques and materials to ensure a safe and reliable connection. The electrical code specifies the types of splicing methods and materials that are allowed for different types of wiring. It is important to follow these code requirements to prevent electrical hazards. There are several different methods of splicing wires, each with its own advantages and disadvantages. One common method is to use wire connectors, also known as wire nuts. Wire connectors are plastic caps that screw onto the ends of the wires to create a secure connection. Wire connectors are easy to use and are suitable for splicing small gauge wires. Another method of splicing wires is to use crimp connectors. Crimp connectors are metal sleeves that are crimped onto the ends of the wires to create a mechanical connection. Crimp connectors are stronger than wire connectors and are suitable for splicing larger gauge wires. Soldering is another method of splicing wires. Soldering involves melting solder onto the ends of the wires to create an electrical connection. Soldering is a more permanent method of splicing wires and is often used in critical applications. Regardless of the splicing method used, it is important to ensure that the connection is properly insulated to prevent electrical shorts. Electrical tape is commonly used to insulate splices. However, it is important to use the correct type of electrical tape for the application. Some types of electrical tape are not suitable for use in wet or damp locations. Heat shrink tubing is another option for insulating splices. Heat shrink tubing is a plastic tube that shrinks when heated, providing a tight and waterproof seal around the splice. When splicing wires, it is important to follow all applicable electrical codes and standards. The electrical code specifies the types of splicing methods and materials that are allowed for different types of wiring. It is important to follow these code requirements to prevent electrical hazards. It is also important to be aware of the potential hazards associated with splicing wires. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical hazards. Before splicing any wires, always turn off the power to the circuit at the circuit breaker or fuse box. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, you should hire a qualified electrician to do the work for you. A fire alarm system is an essential safety feature in any building. It is designed to detect fires and alert occupants so they can evacuate safely. The fire alarm system typically consists of several components, including smoke detectors, heat detectors, manual pull stations, and audible and visual alarms. Smoke detectors are devices that detect smoke particles in the air. They are typically installed on ceilings and walls throughout the building. Heat detectors are devices that detect changes in temperature. They are typically installed in areas where smoke detectors may not be effective, such as kitchens and garages. Manual pulse stations are devices that allow occupants to manually activate the fire alarm system. They are typically located near exits and in other easily accessible areas. Audible alarms are devices that produce a loud sound to alert occupants to a fire. Visual alarms are devices that produce a flashing light to alert occupants to a fire. The fire alarm system is typically connected to a central control panel. The control panel monitors the various components of the system and activates the alarms when a fire is detected. The control panel may also be connected to a monitoring company that will notify the fire department in the event of a fire. Fire alarm systems are designed to be reliable and to operate automatically. However, it is important to test the system regularly to ensure that it is working properly. The National Fire Protection Association (NFPA) recommends that fire alarm systems be tested at least annually. The testing should be performed by a qualified technician. In addition to testing the system, it is also important to maintain it properly. This includes cleaning the smoke detectors and heat detectors regularly and replacing batteries as needed. It is also important to keep the area around the fire alarm system clear of obstructions. A properly maintained fire alarm system can save lives in the event of a fire. Wireless fire alarm systems are becoming increasingly popular in both residential and commercial buildings. These systems offer several advantages over traditional wired systems, including easier installation, greater flexibility, and lower maintenance costs. Wireless fire alarm systems use radio frequency RF signals to communicate between the various components of the system. This eliminates the need for wiring, which can be a significant advantage in existing buildings where it may be difficult or impossible to run new wires. Wireless fire alarm systems are also more flexible than wired systems. They can be easily reconfigured or expanded to meet the changing needs of a building. For example, if you add a new room to your house, you can easily add a wireless smoke detector to the system without having to run any new wires. Wireless fire alarm systems also tend to have lower maintenance costs than wired systems. This is because there are no wires to break or become damaged. Additionally, wireless smoke detectors typically have longer battery lives than wired smoke detectors. There are a few potential drawbacks to wireless fire alarm systems. One is that they are more susceptible to interference than wired systems. Radio frequency signals can be blocked by walls, furniture, and other objects. This can reduce the range of the system and may even cause false alarms. Another potential drawback is that wireless fire alarm systems are more expensive than wired systems. However, the cost of wireless systems has been decreasing in recent years, and they are now becoming more affordable. Overall, wireless fire alarm systems are a good option for many buildings. They offer several advantages over traditional wired systems, including easier installation, greater flexibility, and lower maintenance costs. However, it is important to be aware of the potential drawbacks of wireless systems, such as susceptibility to interference and higher cost. Before choosing a fire alarm system, it is important to consult with a qualified fire alarm contractor. The contractor can assess your needs and recommend the best system for your building. They can also install and maintain the system to ensure that it is working properly. When choosing a fire alarm system, it is important to consider the following factors: the size and layout of your building, the type of occupancy of your building, the local fire codes, your budget. Once you have considered these factors, you can start to narrow down your choices. There are many different types of fire alarm systems available, so it is important to do your research and find the system that is right for you. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or procedure. The AHJ may be a federal, state, local, or other regional department or individual such as a fire marshal, building official, electrical inspector, or others having statutory authority. In many cases, the insurance company will serve as the AHJ. The AHJ has the final say on whether a particular installation meets the requirements of the code or standard. It is important to work closely with the AHJ to ensure that your fire alarm system is installed correctly and meets all applicable requirements. The AHJ may require you to submit plans and specifications for your fire alarm system for review. They may also conduct inspections of the installation to ensure that it is in compliance with the code. If the AHJ finds that the installation does not meet the requirements of the code, they may issue a notice of violation. You will then be required to correct the deficiencies before the installation can be approved. Working with the AHJ can be a challenging process, but it is important to remember that they are there to protect the safety of the public. By working closely with the AHJ, you can ensure that your fire alarm system is installed correctly and meets all applicable requirements.